Okay, today we're going to be talking about two new functions, the x cubed function and the 1 over x function, and what they look like and how to transform them and write equations for them. So this is the x to the third graph. I'm going to start with this one. It's what I call the John Travolta function. I got that from this picture on Saturday Night Live where he's like this kind of a thing. Anyway, that, which you saw in class and didn't see on the video, thankfully, is a representation of this function. Basically, it goes through some points. What? X, y. If I stick in 0, 0 cubed is 0. If I stick in 1, 1 cubed is 1, so it goes through 1, 1, see? And if I stick in negative 1, this one's where it gets a little more weird. When I stick in negative 1 cubed is negative 1 times negative 1 times negative 1, which makes what? Negative 1. So negative 1 goes through right there. And if I put in 2, it's 2 cubed, which should be what? 2 to the third, which is what? 8. Is mine exactly going through 8? No. I was making a rough approximation of it. Now I better get serious about graphing this thing. Over 2 and up 1, 2, 3, 4, 5, 6, 7, 8. Up there. Pretty steep. Okay? And I bet you can picture what's going to happen when I put in negative 2. Negative 8. So, negative 2, negative 1, 2, 3, 4, 5, 6, 7, 8. There we go. All right. There's the x cubed function. Now, it's really just like all the others. If I slap in a plus 5 at the end, what do you think happens to my graph? Goes up 5. What do you think happens if I put the plus 5 on the inside? Like that. It goes left 5. All right, and what happens if I do left 5 and something out there, left 5 and down 7? It just acts like all the others. You just got to know what the parent looks like. All right. The parent function, of course, parents are either a mother or a father, right? And so a parent function, you could call this the mother function if you wanted to, or the father function, of course. But I've been waiting a long time to be able to talk about this next function. This is that parent function, just move 2 to the what? To the left. All right. Well, let's get to the next parent function, which is this guy, 1 over x. It's a very unusual one. All right. 1 over x, the parent on this puppy, looks like this. And this. And it's got something on it that you've never seen before. Okay? It's got a line here and here that it will never touch. It's called an asymptote. In math, it's kind of a funny word, A-S-Y-M-P-T-O-T-E. The asymptote line is a line you get infinitely close to, but you never touch. Why would you never touch it? Let me give you an example. If they have an x and a y, if I put in 1 over 2, for instance, that's going to make a fairly simple thing. X is 2. You're going to get 1 over 2, which is 1/2. If x is 3, you're going to get 1/3. If x is 4, you're going to get 1/4. Do you see how it's getting smaller and smaller? But it'll never actually get to 0, right? Even if I put in x is 100, it doesn't get to 0. It gets to 1/100th, which is incredibly small, but not 0. So that's this line here getting closer and closer and closer to 0, but it'll never touch 0. As if you go out to 1,000, it'll still be at 1 over 1,000. Gets infinitely close to 0. All right. So, again, if I put in like a negative 2, it's negative 2 goes in for x, then I get negative 1/2. And the same thing happens on the negative end of things. Here, it gets closer and closer and closer to 0. If you move this way, You'll get closer and closer and closer to 0, but you never touch 0. So the parent function for this is only two spots that I really care about, and that's 1, 1 and -1, -1. And then the other lines you can just kind of draw freehand, because I don't expect you to have a whole bunch of points on this that are getting closer and closer and closer to 0. You just have to generally get it close like this. One more thing, you should draw in the asymptote lines. I can make them neato because I have a smart board. But for you, just a dotted line running through there. Graphing the asymptotes on the function is a good idea. All right. And now I can shift this function, of course. This is the parent function, except it's been shifted. That's in there by the x. So is it right or left 2? That is right 2. So I'm going to take the whole thing and shift it right 2. And notice I'm shifting the asymptote line right 2. And then this part of the graph shifts right 2. There we go. All right. Okay, so anyway, we just did a shift on that mother function, and we're going to do the domain and the range on this guy. The domain is how far to the left versus how far to the right. Now, do you get it goes forever this way and forever that way, but there is a little spot in the middle that it doesn't ever touch? So the range is a little more complicated now. The range isn't just from domain, negative infinity to positive infinity. That would have been nice, but it's not that simple. There's something in the middle it can't be. What can't it be? You know how you can tell? Look at the function. What number would mess it up? Look in here. What number could you stick in there that would mess it up? A 2, because watch what happens. Then you'll get a 0. Where? On the bottom. A 0 on the top wouldn't be a problem. A 0 on the bottom would be a problem. So at x equals 2, that's the spot that it can't be. You can also do that by just looking at the graph. Do you see how this dotted line is at 2? But it's hard for a lot of people to do that. If you just look at the function, you can tell what would mess it up. So that means this domain can be anything in the world. If I were to do it in terms of a number line, it can be anything in the world except one thing. What's the one thing it can't be? 2. So it can be everything except 2. So how would I write that in interval notation? From negative infinity up until 2, it works fine. Does it work at 2? No, so I use a parenthesis around the 2. And then I start again another one and say from there it works from 2 to infinity. And whenever you have two intervals like this, you put a little u in between them and say union. Okay? So this means this number line is so much easier to understand. Everything works except 2. But you have to be able to write it in interval notation. So interval notation would look like that. All right, now, yes, question? Yes, this number and this number will be the same, if that's what you mean.
Not really, but
Okay, all right. All right, now range. Do you agree that range is the same idea except going in the opposite directions? Do you get it's going to be a lot the same? It's going to work everything except one spot. Okay, in this case, what's the one spot? And you're going this way now. Remember, you're on the y-axis. What's the one spot you can't hit? Is it 0 or is it 2? Coming from the y's perspective, on the y-axis, look for the dotted line here that's stopping our progress. Is that at 2 or is that at 0? That's at 0. Okay, so the range is same idea as this one. It was everything works except 0 this time. And so you'd write it as negative infinity to 0 union with 0 to infinity. The main idea is that you get it. You get that it can't be 0 and it can be everything else. That's what you need to get. The domain and ranges on this one is tough. That's why we're talking about it, because domains and ranges usually are just, negative infinity to positive infinity, or from 3 to infinity. But these get trickier. All right, let's move to this one. Do you agree that it's basically the parent function, except it's been moved? Okay, now let's move it. Where should we move it? What's that plus 3? Is that inside or is that outside the function? That's inside, and therefore it's horizontal on the inside, right? So it's a horizontal move. Should I go left or right? Which way should I go? Plus 3 is left 3. 1, 2, 3 spots. There. That was a little sloppy. Now how about the minus 5? Which does that mean? Down 5. 1, 2, 3, 4, 5. Good. Now, if you put an asymptote line here and here, do you get that the asymptote lines cross right there at the point -3, -5? Does that make sense? Coming from this, which you can't trust and it's the opposite of what you'd expect, and that, which you can trust and it's exactly what you expect. See what I mean? Okay, so now I got my graph moved. What's this domain and range? That's the tougher part. Remember, domain goes this way, and if I'm just this year started to realize this might be a good idea. Since the domain is the x's, I'm going to make my numbers, like when I say it goes this way and this way, I'm going to do that on the x-axis, right? So does it go forever this way? Yeah, so it goes from negative infinity up to, where does it stop? Where does it stop working? At that little dotted line, which is at what? Not 3, -3. Okay, and then it starts working again, and it goes to infinity. So do you get how my range is pretty much right there? Or sorry, my domain is pretty much right there. It's everything works except -3. And then I can just start writing it, instead of like with a graph, I can start writing it and saying, oh, okay, so it's 2 areas. This part of the graph right there is from negative infinity until it hits -3, union with -3 to infinity. How many of you think you could have got that right without me? Be honest. That's almost everybody. Good. Okay. The range. Please do it without me. Remember, the range will be on this line. How far up? How far down? What doesn't it touch? Write it like that, and I'll check you as you turn your paper or turn your iPad my way. I'll tell you if you did it right. I'm going to pause for a second while I do that. Okay, so pretty much everybody was getting this right. It goes from negative infinity until it's -5, and then it stops working. And then we start again at -5, not touching -5, going to infinity. There we go. Okay, you guys caught on to that much quicker than I thought. Nice job. All right, so we got 2 new parent functions. You used to just know parabolas and the V shape and the ramp. Okay, that looked like kind of like that. Now you got the John Travolta function, and you've also got this one, which is the 1/x. It's called the rational function, and it's the first time you've ever seen an asymptote. All right. So if you're going to write an equation for this, these are much easier. You just have to say, okay, here's an equation. Fix it so it's 3 to the right and 4 up. Well, that's really easy. 3 to the right, 4 up. Good. That makes sense? That's easy, isn't it? Okay, good. Write me that one. Do this one. I'll pause for a second while you try. Y equals negative. Okay, you've got a negative in front. That's going to reflect up, down, and that would be over the x-axis. Very good. What comes next? I'm really close to done. Why don't you just finish it? Okay. All right. How many of you agree with him? You're right. Good. All right. So making the equations for these is pretty easy. But this one's got like 7 things in it. See if you can handle this one. It's just an equation just like the last one. It's got a lot of stuff. Try it. A lot of these will be wrong because of parentheses. I've seen 3 different answers so far with 3 different people showing it to me. So be really careful. I haven't said who's right yet. Sigh. That one has potential. Okay, still a bazillion answers, so let me show people, and you'll know whether you got it right or not. All right, so we start with a y equals a 1 over x. Notice I make it big and open so there's lots of room to write. Okay, next, stretch vertically by a factor of 3. That means on the outside, because that's vertical on the outside, right? Vo, high vo, vertical on the outside. There's my stretch by a factor of 3. Now, stretched horizontally by a factor of 2. Where should that 2 go? It should go on the inside. Where on the inside? Just wait. Where on the inside? Right by the x. That's close to right, but it's not right. What's wrong with that 2? Yes, sir? Why does it have to be a half? Counterintuitive, yes. The stuff on the inside is counterintuitive. Now I have a half on my x. Now that's all good. Okay, next thing. I've got that done already. Reflected over the y-axis. How am I going to do that? Negative where? On the inside or outside? On the inside. So that also needs to go in there. Now, this is getting a little messy. I'm going to rewrite this just a little further over. Y equals 3 times all that. Okay. Don't have to have those parentheses there, but it's not a bad idea. Okay. And now, here comes the one where it messed a lot of people up. 4 units right. If you just go like this, do you know where you just messed up? Who knows? What do you know? Parentheses would do it, yes. And that means that, yes, you'd multiply the negative half times both of them, but that parentheses is necessary. Otherwise, you would have had to change it to negative 1/2 x plus 4. Okay. And then the last thing is the 1 down. That's way on the outside here. And a lot of people will put it on the inside of the parentheses and they'd be wrong. How many of you actually did have it right? All right, there's like 6 of you. Good job. Okay, that was a challenging one. And I bet you the parentheses are what got almost everybody. Okay. And by the end of the hour, you should have learned all of these things, and I believe you have. So I'm going to find out as we start our homework together. So everybody take out your homework, the new one, not the old one. The old one, because of technical difficulties, we're going to grade tomorrow instead of today. And I think we'll start the homework together as I pause the video for a second here. Okay, notice that in the folder there's actually a couple different things. They both have keys. All right? So that means your homework, obviously it's not the thing that says notes on it. It's not the readings and videos. It's not just this is a homework. This is a little quiz. We're not doing that right now. So it must be these. And obviously of those, some say key, so that's not what you're supposed to start with, right? So that leaves the 2 remaining ones, that and that. There are 2. Why? Because one of them is for the 1 over x, and one of them is for the x to the 3rd. They're both smallish. So let's start with the one that says 1 over x, the very top one. But there are 2 worksheets for tonight's homework, so. Come on. I'm going to actually do the download file option. Pause for a second, cleaning things up. Okay, so do you remember me saying that all I needed for the parent function on this guy There was only a couple of really important spots, that one and that one. And from the rest, you could just kind of freehand and get it close. You want to get that idea across that it's getting closer and closer, but will never touch 0 in either direction. Okay, so that's good enough for the parent. I don't expect you to have a whole bunch of points on this. Just those 2 key points. Now, should you have the asymptotes? Yeah, but it's really hard for me to see them anyway because they're supposed to be right on the axes. Now this one, it's got a negative in front. You're going to flip it. Ooh, that gets a little weird. So this part right here that gets flipped, is that an up-down flip or a left-right flip? Up-down. So if it's up-down, it goes down there. Okay, and this other part was right here. That part, up-down flip, is going to go up there. Okay, so it looks pretty much the same, but it's kind of like it's been, well, it has been flipped. Here's the really weird thing. If you do a left-right flip, it's the exact same thing as an up-down flip. Try it once, you'll see. If it starts here, do you get why if I do a left-right or an up-down, it's going to end up in the exact same place? It's the only function like that, where a left-right function, or a left-right flip, and an up-down flip, or vertical or horizontal reflection, will end up in the same place. If the parent's the blue one, do you get how the red and the black one happen? Either whether you flip to the left or whether you flip up, you get the same thing. Okay. All right, moving on to a couple more where you're just going to move them around. And I feel like we can probably skip some of this because it's been kind of a long lesson today. So why don't we say we're going to skip 6, 7, and 8. That's all I have for the video for today.